Right, welcome to the deep dive. Today we're going to be doing kind of a streamlined deep dive into the Artificial Intelligence Index Report
Mhm.
2025.
Yeah.
We've got a wealth of information in this report, and
Yeah.
I think our goal today is to give you the key takeaways, the things that will help you stay informed without giving you information overload.
Yeah, that's right. The report is a comprehensive overview of AI across various dimensions. We're going to be touching upon things like advancements in AI model capabilities, a lot on the responsible AI development side, economic impacts, and then really diving into AI in science and education.
So a little bit of roadmap for you today, and I think we want to extract the nuggets, connect the dots, and give you a clear and insightful view of where AI is today. So let's start. Let's unpack this. I think one of the things that just jumps right out at you is how fast this technology is moving.
Yeah.
The report gives some pretty striking examples of this.
Yeah, so I think what's really noteworthy is the sheer pace of progress. In 2023, the AI research community really introduced some challenging new benchmarks designed to test the limits of AI capabilities, and some examples of this include MMMU, GPQA, and SWE bench.
So kind of like increasingly difficult exams.
Exactly. And the performance improvements on these benchmarks in just the following year is quite significant. So we're talking about an 18.8% increase on MMMU, almost 49% jump on GPQA, and SWE bench, which assesses coding ability, went from 4.4% performance all the way up to 71.7%.
Huge. So this really underscores, how quickly these systems are learning.
Exactly, yeah. And it's not just about individual models getting better. It's also the fact that we're seeing a convergence in performance among the top models. So the difference in their abilities measured by ELO scores on the chatbot arena leaderboard has been narrowing considerably.
So the top is getting more competitive, and more really good ones are
That's
available.
exactly right.
Interesting development.
Absolutely. And another key shift to sort of point out with global implications is the shrinking performance gap between AI models coming out of China and the US.
Right. If you go back a year, the U.S. models had a very big lead on these benchmarks. Things like MMLU, math, human evil, and
Yeah, the report details those percentage point differences, which were quite large.
quite substantial. But by the end of 2024, the gap is closing dramatically.
Dramatically. I mean, just to give you one example, on MMLU, the gap was as high as 17.5%, and it's now shrunk down to 0.3%.
Right.
So this leveling of the playing field globally is an important trend.
Yeah, and it's not just between countries; it's also between different types of models. The open weight models are starting to catch up to the closed weight models. Maybe you could explain the difference and why this is potentially relevant to us.
Sure. So open weight models essentially make the underlying code and parameters available to the public, so anyone can use them, build upon them. And closed weight models are proprietary models that are only accessible through a particular company. And previously, open weight models were generally lagging behind in performance, but we're seeing a rapid catch up, so much so that the difference in performance on the chatbot arena leaderboard narrowed from 8.04% at the start of 2024 to 1.70%, just a little over a year later.
Wow. And so what does this mean for the future? I mean, potentially you have access to tools that are more open and more adaptable.
That's exactly right. Yeah, and I think this has important implications because it fosters broader innovation. It allows more researchers and developers to build upon these open models. And now the report does touch on the different perspectives regarding this trend.
Well, yeah, I mean, the whole issue of, open versus closed AI is something that's been debated. What are the main arguments on each side?
Yeah, so those who advocate for open weight models, they highlight that it has the potential to reduce the dominance of a few large players in the field. They also point to faster innovation driven by wider access. Increased transparency can contribute to more robust and secure systems. So models like Meta's Llama series, for example, are a prime example of open weight models that are being used in a wide array of applications and even forming the basis for other open weight models.
Yeah.
And then on the flip side, critics raise legitimate concerns about potential security risks associated with open weight models. The possibility of misuse. This idea that it could be used to spread misinformation or disinformation. So this perspective advocates for a more controlled approach to model development and deployment.
Yeah, it's a complex issue. There are valid points on both sides. Now, there are also some new techniques that AI is using to reason to improve its performance. And one of the things that caught my eye was this concept of what they're calling test time compute.
Yeah.
Could you explain that?
Yeah. So what's interesting about this is that you're allowing the model to essentially dedicate more compute towards thinking through a problem, specifically at the time of evaluation. So one really great example of this is OpenAI's O1 model, which can iteratively refine its reasoning during the evaluation phase. And this led to this remarkable score of 74.4% on a math Olympiad qualifying exam, which is a really, really difficult exam. And just to put that into context, GPT-4o only achieved a score of 9.3% on the same exam.
That is a remarkable improvement.
Yeah, that's what.
But there's got to be a trade-off here somewhere.
Yeah.
I mean, we can't all get super genius AI.
Right.
So what is it?
So the trade-off is that it comes with a significant increase in computational cost and processing time. So the O1 model is significantly more expensive to run and much slower than GPT-4o. So for many practical applications, it's a trade-off between achieving really high accuracy and maintaining speed and affordability.
Right. You can't have an AI that takes an eternity to respond and costs a fortune every time you have an interaction with it.
Yeah.
And there are also some more fundamental limitations of these language models that I think we have to keep in mind, that the report also touches on that.
It does, yeah.
So what do we see?
Yeah, so despite all the impressive progress, complex reasoning still poses a challenge for these large language models. And even with, sophisticated techniques like chain of thought reasoning, they still struggle with tasks that really demand, strict logical deduction, particularly arithmetic and planning. And this struggle is even more pronounced when they're dealing with larger instances of these problems.
Yeah. So they're getting better at mimicking intelligence, but true problem solving is still, has some room for improvement.
Yeah, absolutely.
One of the things that I was interested to read about in the report was this section that they dedicated to benchmarks.
Yeah.
It seems like there's a lot of concern about the quality of the benchmarks.
Yeah. And I think this raises this really, really important point about how we measure progress in AI. And, one analysis that they highlighted was the Better Bench analysis, which identified some, significant shortcomings across many widely used AI benchmarks. We're talking about issues with the statistical rigor of the reported results, a lack of publicly available scripts to reproduce the findings, inadequate documentation, and even benchmarks like MMLU, which are very frequently cited, have these kinds of issues.
So you could be led to, misleading conclusions, misinformed decisions regarding AI development policy and so forth.
Exactly, yeah. And so to address these concerns, Better Bench has proposed a comprehensive framework with 46 criteria for developing and evaluating AI benchmarks. And these cover everything from the initial design to ongoing maintenance. They've also created a public platform to help improve the quality and comparability of benchmarks.
Right, because you need standardized, reliable benchmarking to be able to really, trust these evaluations, make sure that they're meaningful, and then inform responsible development and deployment.
Yeah, absolutely.
Okay, so let's talk about some of the specific areas of advancement. The report goes through the different modalities: language, image, video, speech, coding, reasoning, and then robotics. So starting with language, what are some of the the key takeaways there?
Yeah. So in language, we already touched on this, but we're seeing this continued convergence in performance among the top models on the LMS/YS chatbot arena. The report highlights some of the leading models as of January 2025. They also introduced the Mixable framework, which aims to provide a more comprehensive assessment of language models by combining various evaluation benchmarks. Models like Claude 3.5 Sonnet and OpenAI's O1 Preview demonstrated strong performance on the challenging Mixable Hard benchmark.
And there's also this thing called retrieval augmented generation.
Right, yeah, RAG.
Or RAG.
Yeah.
What is RAG for those of us who aren't in the weeds of AI jargon?
Yeah, so a RAG is a technique that enhances language models by enabling them to access and incorporate information from external knowledge sources. So it's sort of like giving the AI the ability to look things up in real time. And this allows the AI systems to stay up to date, provide more reliable information rather than being limited to just, the data they were initially trained on.
Yeah, makes sense.
And then also just to highlight one more thing in the language area, the report notes the development of new evaluation tools, specifically for long context models. So models that can process really long pieces of text. And one example is NVIDIA's Ruler. And interestingly, Ruler's findings suggest that many large language models don't maintain their advertised performance when processing very long pieces of text.
Interesting.
Yeah.
What about image and video?
Yeah. So in image understanding, one significant achievement was AI finally reaching human level performance on the visual common sense reasoning, or VCR benchmark. For video, they introduced the MV bench, which is designed to test more complex video understanding that requires reasoning about events over time.
Yeah.
In generative models, the progress has been quite remarkable, as you've probably seen with things like the which faces real challenge, the rapid improvements in mid-journey generations, and the chatbot arena now also includes a vision arena, specifically for evaluating image generators.
And video generation, which has seen some really, some really compelling demos lately.
Yeah, absolutely. So we saw the release of stable video diffusion, and then OpenAI's Sora really made a huge splash with its ability to create realistic and coherent videos. Meta's Movie Gen also received some notable upgrades with advanced editing capabilities, and Google's Veo and Veo 2 are reportedly outperforming competitors based on internal evaluations and user feedback.
Wow. Okay, what about speech?
Yeah, so in speech recognition, the model Whisper Flamingo set a new state-of-the-art word error rate on the LRS2 lip reading benchmark. However, the report suggests that this particular benchmark might be, approaching its limits as the error rates are already, very low.
Right. So you're kind of hitting a performance ceiling there.
Yeah, potentially.
What about coding?
Yeah, so coding saw a significant milestone with Claude 3.5 Sonnet reportedly achieving 100% on the human-TiVol benchmark. So being able to solve these challenging programming problems. However, a new and more demanding benchmark called Big Code Bench has been introduced, and even top-performing models like OpenAI's O1, still score relatively low on this benchmark. So it highlights that while AI is becoming very skilled at certain coding tasks, there's still a gap to achieving, true human-level coding proficiency.
But it's one thing to be able to generate a simple piece of code, but to be able to navigate, intricate systems and debug and work across, different components is a much, much more complex challenge. Now, reasoning is clearly a fundamental aspect of intelligence.
Right.
What are we seeing in the report about the current state of AI reasoning?
Yeah, so we saw Alpha Geometry 2, a neurosymbolic AI system, achieve this really impressive feat by solving a difficult IMO, or International Mathematical Olympiad geometry problem, in just 24 seconds.
Wow.
On the benchmark front, MMMU, which is this massive multimodal reasoning benchmark designed for expert-level AGI, saw quite significant progress. OpenAI's O1 achieved 78.2%. So rapid progress, but still below human expert baselines. There's also been notable progress on the ARC AGI benchmark, which is a really challenging test of general AI capabilities. OpenAI's O3 model reached 75.7%, and with a high compute budget, even reached 87.5%.
Wow. Okay. And then finally, robotics, an area where I think a lot of people have been anticipating, big breakthroughs.
Yeah.
What are some of the key updates from the report?
So 2024, really, we saw an increase in the development and capabilities of humanoid robots. So Figure AI introduced its advanced Figure O2 robot, which is capable of tasks like making coffee, assisting in assembly, even using speech-to-speech reasoning through integration with OpenAI's models. And Tesla's Optimus and Boston Dynamics Atlas also continue to make advancements in terms of how robots learn. We've seen progress with with techniques such as AutoOT, which uses reinforcement learning from diverse data, SerArt, which improves the efficiency of transformer models for robotics, and we're also seeing foundation models specifically designed for robotics emerging, like NVIDIA's Geo00T.
And of course, for the average person, I think the thing that's most tangible is the driverless vehicles.
Right.
So, Waymo's rider-only miles continue to expand. Robotaxis are seeing rapid growth and increasing affordability in China with companies like Baidu's Apollo Go and Pony.ai.
Yeah, absolutely.
And it seems like all of these things, the improvements in reasoning, the development of foundational models, the progress in robotic learning are starting to come together, which does point to, more sophisticated robotic systems potentially impacting our lives. Okay, so that's a lot about the technical advancements. Let's switch gears a little bit and talk about the economic trends, which are going to have implications for all of us.
Yeah, definitely. And 2024 saw a number of significant economic events in the AI sector. So these include Microsoft's hiring of key personnel from Inflection AI and licensing of their models. We also saw some major funding rounds for AI cloud infrastructure startups like CoreWeave, data annotation companies like Scale AI. Google acquired the co-founders of Character.ai and licensed their technology. And we also saw some funding for AI chip startups like Grok. So a lot of activity, a lot of money flowing into the space.
So a lot of capital is flowing into AI related businesses. What about the job market? Are there some shifts that we should be aware of?
Yeah. So globally, the proportion of AI job postings relative to all job postings has shown a steady upward trend since 2014. Certain countries like Singapore, Luxembourg, Hong Kong exhibit particularly high percentages of AI-related job openings. In the U.S., we're seeing increasing demand for specific AI skills, so expertise in multimodal models, ARVIS, retrieval augmented generation, generative AI, and conversely, we've seen a decline in demand for skills related to things like GANs or generative adversarial networks, text-to-speech models. So the skills that are in demand are evolving. In the U.S., California, Texas, and New York continue to be the states with the largest proportion of AI job postings, and the proportion of AI jobs within those states is also on the rise.
So certain skills are becoming more highly valued,
Right.
and the concentration in certain geographic areas is becoming more pronounced.
That's right. Yeah.
What about the rate at which these skills are being adopted across different regions?
Yeah, so Israel currently leads in terms of the relative penetration rate of AI skills within its workforce. And interestingly, countries like India, Costa Rica, Portugal, Cyprus, Brazil, Estonia have shown significant percentage increases in their concentration of AI talent.
So it's not just limited to the usual tech hubs anymore.
Right.
The report also mentioned this study by Anthropic that looked at the real world use of their Claude model.
Yeah.
So what was interesting from that?
Yeah, so what they did was they looked at how users were interacting with their Claude AI model, and they categorized them by occupation, and this provided some really valuable empirical data on the integration of AI across various sectors of the economy and different job roles. So really understanding where and how AI is being applied in the real world.
Yeah, and that kind of real world usage data is incredibly valuable. Now, what about overall investment trends in AI?
Yeah, so the U.S. Continues to lead in the number of newly funded AI companies, significantly surpassing the U.K. and China, both in 2024 and over the last decade. And in 2024 specifically, investment was particularly concentrated in areas such as AI infrastructure, fundamental research, AI governance, and then also applications related to business operations and content creation.
And are we seeing tangible benefits for organizations that are adopting AI? Cost decreases, revenue growth, these kinds of things.
Yeah, so survey data from McKinsey and Company indicates that organizations are indeed experiencing both cost decreases and revenue increases as a result of implementing, both analytical and generative AI across various business functions. We're also seeing this huge increase in the overall adoption of AI by organizations globally. The use of generative AI more than doubled between 2023 and 2024.
Wow. So, from 34% to 71% of organizations.
Exactly.
Wow, that's huge. And then finally, what about the impact of AI on overall productivity?
Right. Yeah. So research in software development has shown that there's a correlation between the use of AI assistance and increased rates of task completion. We're also seeing more efficient core coding activities among developers. And interestingly, some studies suggest this kind of productivity equalizing effect, where workers with lower initial skill levels often see larger percentage gains in productivity when they use AI tools. And additionally, a survey that was conducted in Romania found a strong link between the comprehensive integration of AI within organizations and significant improvements in employee productivity.
Okay, so it sounds like it has the capacity to boost productivity across many different areas.
Yeah, absolutely.
All right, let's turn our attention to the impact of AI in science and medicine.
Yeah.
And here, I think the report really highlights some fascinating developments.
Yeah. So, I mean, this is really an area where we're seeing, immense promise for AI. 2024 saw this, big rise in the number of AI-enabled medical devices receiving FDA approval. So you're seeing, real-world application of AI in healthcare. There's also this growing excitement around the potential of using synthetic data in medicine for things like identifying social determinants of health, accelerating drug discovery, and as we've already mentioned, a wave of large-scale foundational AI models specifically for medical applications were released in the past year.
And the Nobel Prizes that were awarded, for research that was significantly enabled by AI, I think really highlight the impact it's having.
Absolutely. So the Nobel Prize in chemistry went to the work on AlphaFold in predicting protein structures,
Hmm.
and the Nobel Prize in physics recognized foundational contributions to neural networks. And then the report also talks about this concept of virtual AI labs. So where AI powered agents can collaborate autonomously on research. And one really compelling example is this lab that successfully designed nanobodies capable of binding to the SARS-CoV-2 virus.
Wow, that's amazing. What about AI's role in understanding proteins?
Yeah, so the report notes that there's been this substantial growth in publicly accessible protein science databases like UniProt, PDB, AlphaFold, and this is partly driven by AI-powered research. We're also seeing an increasing proportion of scientific publications focusing on protein research that utilizes AI, and one capability that's particularly exciting for drug development is AlphaFold 3's ability to model interactions between small molecules and proteins, and this is open source, so it's accessible to the scientific community, which is a significant advantage.
Now, one of the things that comes up a lot is the limitations in terms of the availability of data to train these models.
Yeah, that's right. Yeah, so the report highlights that the training data used for many deep learning algorithms in medicine is geographically concentrated in the U.S., which raises concerns about how well these models will perform on diverse populations elsewhere. There's also a scarcity of publicly available 3D medical imaging data sets. And when you compare the sheer volume of data that's used to train medical AI models to the data that's used for general purpose AI models, the difference is quite substantial.
So it's a significant gap.
Yeah.
But we are seeing some interesting progress in applying AI to various medical domains, imaging, diagnostics, these kinds of things.
Yeah, absolutely. So we're seeing different types of foundational AI models for medical uses. So things like models that analyze 2D images, models that process large pathology slides, these really sophisticated vision language models that can can combine, medical images and text to enhance, diagnosis and reporting.
Mm.
But the challenges related to limited data and ensuring that these models work well across different patient groups, remain. The report also looks at the performance of large language models on medical data sets, and they note the trade-off between, the cost of running these models and the accuracy in medical contexts.
And what about the potential for AI to, directly assist physicians in making diagnoses or treatment decisions?
Yeah. So one randomized controlled trial that evaluated GPT-4's assistance in diagnostic reasoning found that while GPT-4 alone outperformed both physicians who were assisted by AI and those who were not, actually integrating AI into clinical workflows, presented significant challenges. Another study that investigated GPT-4's impact on clinical management decisions suggested that near autonomous AI support might be feasible in certain scenarios, although it could potentially involve a trade-off in the time physicians spend on each case.
So it's a tool, but we're still figuring out how to use it.
Right. Exactly.
The report also mentioned AI's role in understanding social determinants of health.
Yeah.
Why is that important?
Yeah, so being able to extract information about social determinants of health from electronic health records and clinical notes can help healthcare providers identify and address social factors that influence health outcomes. So things like housing stability, access to nutritious food, these kinds of things, and fine-tuned language models are showing promising results in this area with larger models and the use of synthetic data leading to improved accuracy. And we're seeing AI being increasingly integrated with data on social determinants of health across various medical fields.
Right. And then finally, beyond medicine, what are some of the notable model releases in other scientific domains?
Yeah, so some examples include Orinal's Orbit model for climate science, Google DeepMind's GenCast for highly accurate weather forecasting, and then also exciting progress in quantum computing. So Google DeepMind and Google Quantum AI's development of the Alpha Qubit and Willow chip, which achieved this significant milestone in reducing errors in quantum computations.
Wow. So AI is really pushing the boundaries of discovery across so many different disciplines. Okay, the final deep dive is in AI education.
Yeah.
How is AI changing the way we learn and the way we're preparing future generations?
Yeah, so this chapter really emphasizes, the need to equip students with the knowledge and skills to be both responsible users and capable developers of AI, and it really underscores the importance of building AI expertise, starting at the K-12 level, continuing through higher education, and these efforts should be closely integrated with broader computer science education initiatives.
And so what is the state of K-12 computer science and AI education in the U.S.? Are we seeing improvements in access and enrollment?
Yeah, so there has been a modest increase in both access to and enrollment in high school computer science courses across the U.S. However, significant disparities persist, based on factors like race and ethnicity, the size and socioeconomic status of the school, geographic location, and the report includes, data that clearly illustrates these inequalities in the availability of foundational computer science courses. Girls also continue to be underrepresented in computer science education.
So there's still work to be done to ensure equitable access.
Absolutely.
What about post-secondary education in computer science and AI?
Yeah, so the U.S. saw a near doubling in the number of master's degrees that were awarded in AI between 2022 and 2023, and this could signal a future trend for other levels of academic degrees, and then data from the OECD provides kind of a broader global perspective on the number of new graduates in information and communication technologies across various degree levels.
Right. So while the number of advanced degrees is increasing rapidly, the broader landscape of AI education is still developing.
Yeah, absolutely.
Well, this has been a really thorough deep dive into the Artificial Intelligence Index Report 2025.
Yeah.
We've covered a lot of ground. We've explored these rapid advancements, the economic landscape, the impact on science, and